everyone, welcome back to my YouTube channel. So today we are going to solve day 3 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with the today's problem. Problem number 3625. Count number of trapezoids 2, right? So this is hard level problem marked by LeetCode, and this problem is actually hard, right? And in this problem we will do a lot of mathematics actually, right? So let's get started. Let's read the problem statement first. So you are given a 2D integer array points where points of I is equal to x and y, which represents the coordinates of the ith point on the Cartesian plane, right? We have to return the number of unique trapezoids that can be formed by choosing any 4 distinct points from the points, right? Any 4 distinct points we have to choose, right? And what is trapezoid? A trapezoid is a convex quadrilateral with at least one pair of parallel sides, right? And 2 lines are parallel if and only if they have the same slope, right? Okay, so let's see this example, right? So here these are 5 points given to me, right? So let's say this is P1, this is P2, this is P3, this is P4, and this is P5, right? So here if I mark these points, so here if you see, this is nothing but 0, 1, 2, and this is 3. This is nothing but 1, this is 2, this is 3, right? Same way here it is -1, -2, -3, and same way this side if you read it, -1, -2, -3. Okay, so now this point is nothing but -3 and 2, right? So -3 and 2 is nothing but P1. This is point P1, right? -3 on x, right? X and y given to us, right? So -3 and y2. Okay, this is point P1. And same way here, this is nothing but in the x, if you see 2 and here 3, so 2 3 is nothing but P3. So this is nothing but point P3, right? Same way here, this is on x3 and on y2, so 3 2 is nothing but P4. So this is point P4. And this is nothing but -3, and here on x, actually first we need to check on x. X is 2 and here -3. 2 minus 3 is nothing but P5, right? So here if you see this, so this and this side, right, both are parallel to each other, both are having same slope, right? Both are having same slope. Now question is how we are going to calculate the slope, and what is this slope, how to calculate this, right? So first let's understand this diagram, right? So they are parallel, so we are going to discuss about this also, what is slope. Same way here if you see this and this, so both are parallel sides, right? This and this, so this is also one valid, right? So output is 2, only these two shapes are valid, right? So the points -3 2 2 3 3 2 2 -3 form one trapezoid, and these points also form another trapezoid. Okay, right? So this is what we need to do, right? Here if you see this and this, both are parallel, so 1, right? And if you see the constants, so points dot length is starting from 4 to 500, right? And x of I, y of I value is also from -1000 to 1000, and all points are pairwise distinct. Okay, now here in all these shapes you may think that we are only discussing about 4 points every time, right? Here also if you see, we are discussing about 4 points, right? 4 points, 4 points, 4 points, right? So is it possible that I run 4 loops, 4 loops, right? One is I loop, J loop, K loop, L loop, right? And step by step I pick 4 points. Maybe I is picking P1, this is picking P2, this is picking P3, and this is picking P4, right? This is very brute force actually, brute force, right? Can I do this? Can I do this? Can I pick 4 points every time and then just find the slope of 2 lines, right? 4 points means definitely we will have 2 lines, right? Here I can see these 2 lines, or I can see these 2 lines, right? We will form one shape, right? It may be possible, it may not be possible. Maybe all the points P1, P2, P3, P4 exist on same line, then maybe shape will not form, right? But if I have 4 points, then maybe I can do one thing. P1, P2 slope I will find, P3, P4 slope I will find, P1 P3 slope I will find, P2 P3 slope I will find, something like this, right? Can I do this? Can I do this? Can I run for loops? No, I can't run. Reason is this length is 500, right? And I am running 500 times this, 500 times next loop, 500 times next loop, 500 times. So this is nothing but 500 par 4, right? Right? So this will definitely give you time limit exceed error. So definitely we can't do this, right? Okay, so let's see here. What is trapezoid? A trapezoid is a convex quadrilateral with at least one pair of parallel sides. So if we want to count trapezoids, we need any 4 points that form a quadrilateral where at least one pair of opposite sides have equal slope, right? But instead of going over all the 4-point combinations, O raised to power O into n raised to power 4, impossible for n is equal to 500, right? So we have to reverse the thinking here, right? So we can't do this, right? Okay, so what is trapezoid? Okay, so how we are going to determine it? So a trapezoid is determined by choosing two parallel segments. What is segment? Segment is nothing but just a line between 2 points, right? So segment A between points P1 and P2, right? So this is segment A, I can say, between point P1 and P2. Segment is nothing but just a line, okay? So a trapezoid is determined by choosing two parallel segments. Segment A between points P1, P2, segment B between points P3 and P3 and P4, right? And if slope of these 2 points is equal to slope of this point, right? And the pairs do not reuse points, right? There is no common point, right? There is no common point, right? If there is a common point, right, P3 exists here or here, right, then we may not form shape, right? So, and the pairs do not reuse points, right? Then the 4 points automatically form a quadrilateral with one pair of parallel sides, meaning it's a trapezoid, right? Okay, so let's see what we need to do here. Okay, so this problem reduces to group all the segments by slope, right? For all the segments, that different segments we can form, and segments is nothing but the combination of 2 points P1 P2, right? P1 P3, P1 P4, P1 P5, right? Then maybe P2 P3 you select, then P2 P4 you select, then P2 P5 you select, then maybe you move to P3 P4, P3 P5, and then maybe you select P4 P5, right? So here 1 2 3 4 5 6 7 8 9 10. Okay, 10 I am discussing here actually, right? So here we have to group all the segments by slope. For every slope group, suppose we have to count the number of distinct point pair segments having this slope, right? We have to just calculate the segment slope, right? M. We usually denote slope with M. What is the slope? We will discuss. Okay, and each slope contributes trapezoid is equal to count by 2, right? And because each pair of segments create one trapezoid, right? Each pair of segments. So if these two pairs of segment you take, right, two pairs of segment you are taking, right, so they are just contributing one trapezoid, right? One trapezoid if they have parallel slope, right? So that is why I'm writing it like this, right? So how many they are going to contribute? They are just going to contribute one, right? Each pair of segment, right, creates one trapezoid, right? Each pair means two, right? Okay, and creates one trapezoid. Okay, now here maybe if you have segments like this here, 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 right? So then how much it will contribute, right? So in that case it will contribute, right? This is one, right, which can contribute, right? This can contribute here too, right? And if these two lines are parallel, right, here and instead of here both are parallel, then they may also contribute, right? But here I'm just diagrammatically I'm showing you in the same line, then it will not, right, it will not consider, right? So we will discuss about all these things, right? But I hope that you guys are clear with this, right? So here, that's what. Okay, here I'm discussing some pair of segments are invalid because they share a point P1 P2 and P2 P3, then will not form a quadrilateral, right? So we have to remove all this stuff, right? And they lie on the same infinite line, right? So for example, points are all on y is equal to 2 line, right? So y is equal to 2, right? So y is equal to 2 line, right? So this is y is equal to 2, let's say, right? Parallel segments are there. One line is this, let's say, or another 2 points lie on this same line or somewhere here, right? But not a quadrilateral, right? They must also be removed. So we have to take care of this stuff as well. Okay, done. So we have to do counting the segments by slope, right? Then counting groups of points with the same x when slope is equal to infinity, right? Counting group of points with the same line equation when collinear, and subtracting combination inside each invariant group. This ensures only true 4-point quadrilaters are counted. Okay, so we will discuss all this stuff. Okay, don't worry, this stuff, right? Okay, so now let's understand what is segment. Right now we are just going to cover few basics actually. So segment is just a straight line between 2 points, right? So here if you see, let's say we have 3 points A, B and C, right? So AB is one segment, AC is one segment, BC is one segment, right? So possible segments are AB, AC, BC, right? And here these 2 points are connecting, right? We are connecting these two points, right? So if you have n is equal to 3 points, then there are how many number of segments, right? How many number of segments? So that simply means we have 3 segments, right? And I have explained this yesterday actually in part 1 of this problem, right? So both problems are different little bit, okay, not same, right? So that simply means if we have 3 points, right? Now from these 3 points, how many different combinations of 2 you can form, right? Out of 3. So see 3 comma 2, this is how you write. This is nothing but 3 factorial, 3 minus 2, 1 factorial and 2 factorial, right? So that is nothing but 3 and 3 in, that's nothing but 3 only, right? So this is nothing but 3 into 2 factorial, and 2 factorial, 2 factorial cancel out, so 3 only, right? So that's what. Okay, so if you have n is equal to 3 points, there are these many segments. All right, now what is the slope of a segment? Very important thing that we are going to use in this problem. The slope tells how steep a line is and was defined in the problem, right? So two lines are parallel if slope is same. And how we calculate the slope? We calculate a slope like this: y2 minus y1, x2 minus x1. Now same example I'm taking. Let's consider this segment AB, right? So AB, that's simply 1 2 2 5 6, right? So now I'm going to consider this as my x1 y1 and this as my x2 y2, right? So now y2 minus y1, that simply means 6 minus 2, 4 dy. We can write dy is nothing but y2 minus y1. Same way dx is nothing but x2 minus x1. So 5 minus 1, 4, right? That's it. So slope is going to be your dy divided by dx, or you can write it as y2 minus y1 y x2 minus x1. So this is slope. So slope of this line is 1. Okay, now very important thing, one very important thing. So when you are going to calculate, let's say this is a segment AC, right? 1 2 2 1 6. So you are going to calculate this dy dx similar to this one, right? Now here you have to do this dy by dx, but dx is 0, right? So dy by d 0. So this means anything, any number we divide it with 0, we are going to get infinite. So when slope is infinite, in that case simply you can say that it is nothing but a vertical line. Okay, when slope is equal to infinity, that simply means vertical line. Okay, now here in this example, okay, in this example if you see, so let's calculate the slope of this line. So this point is nothing but 3 comma 0, right? And this point is nothing but 3 comma 2, right? So tell me dy by dx. Dy means you can say, you can take it as x1 y1, and you can take it as x2 y2, right? So you can say 0, maybe you can take y1 minus y2 or y2 minus y1, right? It will not get any impact, right? Sign will automatically cancel out. Okay, so here let's say this is nothing but 2, but here in the down you will get 0, right? So if you see, this is nothing but a vertical line only, right? Same way here also you are going to get vertical, right? So whenever your slope is infinity, you will get a vertical line. Okay, done, done, right? So this is clear. Same way here, if you take this segment, so in this you are going to get above value as 0 and below as some value, right? Below as some value, right? 0 or 3, some value, right? Anything here, maybe negative x, right? So in that case you will always get 0, right? So when your slope is 0, that simply means we are dealing with horizontal line, right? So I hope that these two cases you are clear. Okay, we will use all this stuff actually in our problem, right? Okay, so this is done, right? So now here, why do we store slope as reduced this, right? Reduced of dy by g and dx by g. Why we need to do it like this? See this example. So here you are going to get 4 by 2, right? In this case also you are going to get what, 4 by 2, right? Here, see, for this one what is the gcd, common value, greatest common divisor? So 2, so I can write it like this now, 2 by 1, I can write it like this. Same way here also I can write it like this, 2 by 1, right? Okay, so now both are matching, right? So we have to find the common slope now. So let's do the gcd, right? So that we get the same value, right? I don't want to leave it as 4 by 2 and I am going to write it like this 2 1. I don't want this, right? So if I can further reduce it to 2 by 1, so let's write it now like this. Okay, so that's a simple meaning, right? So that's why we reduce, right? So gcd of this, so you can reduce it like this 2 by 1, right? Thus both became to 1, same slope, parallel, right? So let's reduce it, right? It's not like somewhere you calculate this and you somewhere you calculate this, so you are going to say that both are not equal. No, these are equal, right? So if you just divide it with 10, the gcd of these two, you will get 2 equal to 1, right? So that's why, right? So we need to write it like this, right? Okay, now next question, what is this intercept? What is this intercept? Right, a line is infinite, right? A line is infinite, right? A segment is only a part of that line. Line is infinite, right? A segment is only a part of that line. So if two segments, right, have same slope, they lie on exactly the same infinite line, right? Then they should not form a trapezoid, right? Clear? So let's say this points on the same line, y is equal to 2, right? So here see, y point is same, right? So this is nothing but y is equal to 2, infinite big line, right? So points 1 comma 2, right? 1 comma 2, let's say here, then 4 comma 2 is here, then let's say 9 comma 2 is here, right? So 1 2 4 2, let's say this is line A, right? 4 2 2 9 2, let's say this is line B, and 1 2 2 9 2, let's say this is line C, right? So all slopes 0, that simply means horizontal. This we already know, right? When slope is 0, horizontal, but they lie on one infinite line, right? They will not form a quadrilateral, right? So we subtract these from valid trapezoids. Definitely we have to subtract these, right? Okay, so if I am just considering that if a slope is the same for any line, then they will definitely form a trapezoid, right? So if I'm considering like this, then I may be wrong, right? Because of this case. So first I will just calculate the parallel slopes, right? How many different parallel slopes, right? So I will calculate the number of trapezoids I can form overall, right? Later on I will consider this case also. So I'm going to subtract these from the valid trapezoids, right? So this is my plan actually here. Okay, right? So there are a lot of things, right? But still we are able to save some time because of this right, this stuff that I already did. Okay, so how do we check if two segments lie on the same line? How I'm going to check that, right? If the two segments, right, they lie on the same line, right? Segment B, segment S2, segment S1, line 1, something like this. Okay, so there is actually one equation, ax plus by plus c is equal to 0. We use the line equation in the reduced form. So this is nothing but a line equation in a reduced form. I said a lot of mathematics. Okay, so from 2 points we compute a normalized tuple ABC, right? Okay, so how we are going to do this, let's see. Okay, so let's say these two are the points P1 and P2, 1 2 4 2, right? So here in this case, uh, the y value, here we have to write it like this now: ax plus by plus c is equal to 0. I know if you just look at these points, just look at these points, this is 2, right? So means here if you see, I will get some horizontal line, right? So that simply means I will get y is equal to 2, right? Horizontal line, right? 2, right? So when I'm going to get y is equal to 2, when this value is going to be 0, this value is going to be 0, and this is going to be 1, right? And this value actually is going to be minus 2 actually, right? So if you just somehow put 0 here, put 1 here, and in C just put minus 2, you will get this equation, right? Right, you will get this. So you are going to get a b c as 0 1 minus 2. I will show you how we are going to find out a, b, and c. Here I'm just giving the shortcut, right? I will show you also. Okay, so any other segment on the same line will also give you same value of ABC, right? Any other segment on the same line, if they are on same line, they will also give you the same value of ABC, right? Okay, so we detect this. What is this? Collinear sets. Okay, we detect this collinear sets. Okay, this is done, right? So now here, uh, how we are going to do this? So let's see this one example. So take 4 points, right? So here a segment AB, so you will calculate the slope, right? D by dx, right? Segment CD, so here you will calculate the slope. Okay, done. So slopes match, right? Slopes are matching here. Okay, so parallel, they can form a trapezoid, right? So a to b, a to b, right? So how we do? Y2 minus y1 and x2 minus x1, 0 divided by 4. So you are going to get what? 0 only, right? Clear? And here also you are going to get 0 only, right? Slopes are matching, parallel, they can form a trapezoid, right? Okay, but we have to check if they lie on the same infinite line or not. That's what we need to check. Okay, so a and b, if you see this, they both lie on y is equal to 0, right? C and D, they both lie on y is equal to 3, right? So different c values, right? Different c values, right? So not same line, not these c values, different slope values, right? Different y values, if you see, right? So here actually if you write it like this, ax plus by plus c, so in first case you are going to get y is equal to 0, so a is equal to 0, this is 1, and this is 0, right? And in next case when you are going to get y is equal to 3, that in that case 0, this will be 1, and this will be, I think, minus 3, right? So both are things are different, right? So both the things are different, then simply means that they are not intercepting, right? That simply means that they can form a trapezoid, right? These two lines are having same slope and they are not intercepting, right? So that simply means that they are not part of same line, right? And they can form one trapezoid. Okay, so that's what you can do. Okay, okay, so this is done. I don't know why here it's, okay, slope we are going to get 0. Okay, and that's it. Slopes match, parallel, can form a trapezoid. Okay, a b lie on y, this different c values. Okay, and different c values, right? If you see this c, actually we are talking here, not this c. Okay, and not same line, so they form exactly one trapezoid. Okay, clear, this is done, right? Now this part I want to show you how we are going to derive this. So when you have given 2 points, right, x1 and y1, x2 y2, right, so you are going to calculate a as y1 minus y2, right? You can calculate b as x2 minus x1, and you can calculate C as x1 into y2 minus x2 into y1, right? So this is how you are going to compute. Let's see some example here. These 2 points, right? So here y1 is equal to 2 and y2 is equal to 2, right? So change is 0, right? X1 is equal to 1 and x2 this 4, right? So here y1 minus y2 you get 0, and b you are going to get x2 minus x1, right? Just apply the formula, right? X2 minus x1, so you are going to get 3, and c you are going to calculate this as x1 into y2 minus x2, so you are going to get this. Okay, so you are going to get something like this. So in this case you get y is equal to 2, right? Y is equal to 2, and if you see a is equal to 0, b is equal to 1 we are getting, and c is equal to minus 2, right? Here I'm doing one more thing na. In this equation we have 0, 3 and minus 6, right? So actually I'm calculating the GCD of all this. So GCD is going to be 3, greatest common divisor, right? So I'm going to get 0, 1, and here I'm going to get minus 2, right? So I will try to do GCD here as well, right? Normalize, I am going to normalize this. Okay, done. This part. Okay, clear. Now same way, vertical line again, just go over these examples, right? A y1, here I'm calculating a value, b value, right, and c value. Then here if I get something like this, right, see here I'm making somehow I'm making x as positive here, right? So minus 7x is equal to minus 35. I'm just going to cancel out, I will get x is equal to 5, right? This is what I'm getting, right? So we have to normalize the sign as well, right? So multiplying by minus 1 to make a positive, so somehow I make my a positive, right? So I will get this, right? So that is nothing but 7 0 minus 35, and GCD is 7, so you can get all the numbers are completely divisible by 7, right? So you're going to get 1 0 minus 5, right? So that's it. Okay, done. Same way here, one more example, right? You get this, then here normalize the sign. Okay, right? So you're going to get something like this, then you can GCD, calculate the GCD, then do this, then you will get something like this. Okay, positive slope line, then negative slope line. These are the points. Just go over this example, same thing I'm doing, right? So you are going to get this, and you have to divide with GCD, and you're going to get this. Okay, same way here, same example actually. Calculate this multiply by minus 1, normalize it, you are going to get this, then calculate the GCD, and then write it like this. That's it. Okay, so this is how we are going to write. Okay, and now what these a b c value mean? So a and b are identical, that simply means that we have parallel lines, right? Same line if all are identical, a b c, right? That we have seen above, right? If we get same value of a b c, right, identical. Different lines when a b are same but c value is different, that we have seen here now. Somewhere here we have seen, right? A and b are same, right? In these two things a and b are same but c is different, that simply means different line. If everything is same, right, if everything is same, right, so that simply means that both the lines are existing on the same line, right? So this is actually what we are doing here, right? Lot of maths actually. Yeah. All right, so here two horizontal lines, y is equal to 2, y is equal to 5, right? So here a and b are same, c is different, so they are parallel. Okay, but same line, no, right? So exactly what we need for trapezoid. This is what we need, right? Okay, what is intercept? So in slope intercept form, we write y is equal to mx plus b, something like this we write, right? In the slope intercept form, right? M is nothing but the slope, b is nothing but the bi-intercept, where line crosses y-axis. Remember this point. B is nothing but the bi-intercept where line crosses y-axis. So we want the formula for this b, right? We want the formula, right, of this intercept. Okay, so I can write this equation like this now. B is equal to y minus mx, right? So here I'm just saying the point as x1 and y1, right? Okay, now M, I can write it like this, na, y2 minus y1, x2 minus x1, that is nothing but dy by dx. This is how you calculate the slope. This you already know, right? Now if you place all this stuff here, right, in this equation here, so you are going to get something like this, right? So this exactly is what I am planning to use in my code, right, to calculate the value of the intercept, right? That's why I'm mentioning it here. This is how actually I'm going to derive this part. Okay, clear? All right. Now there is one more thing I'm trying to use here. That is nothing but in my code, midpoint. Okay, midpoint. So segments have same slope. I'm going to use this, and they can have same midpoint. This is very dangerous case. This is very dangerous case. Okay, why? Let's see. So consider these 4 points, A, B, and C, D, right? So A and B and C and D, right? If you calculate the midpoint na, of A and B, midpoint 0 plus 4 divided by 2, and here 0 plus 4 divided by 2, you are going to get 2 comma 2. Here also for C and D, you are calculating the midpoint 1 plus 3 divided by 2, 1 plus 3 divided by 2, you are going to get 2 comma 2, right? Same midpoint, right? Same midpoint you are getting for these two. Okay, same midpoint somewhere here, right? 2 comma 2, right? Okay, now for this, if you see, all 4 points lie on the same line, right? All the 4 points lie on the same line, y is equal to x, right? And here these are the segments A, B, and C, D, right? So they have the same slope, they have the same midpoint, right? But why we need to make this pair to be subtracted, right? So because A, B and C, D are collinear, they are not separate lines, they do not form a quadrilateral, they do not form a trapezoid, they lie on the same infinite straight line. If you treat A, B and C, D as parallel segments, you would incorrectly count them as trapezoid, right? So this midpoint actually is going to help me in my code. Okay, so let me show you a few more things here. So I'm going to store the mid key, right? Instead of normally writing the mid key, as I will just generate one hash key actually here, hash key, right? So if I store mid key, like I generate the hash key like this, x1 plus x2 plus y1 plus y2. So this is going to cause the collisions because different pair of points can produce the same sum, right? Let's produce it with some, let prove it with some example, right? So here if you see A and B, these 2 points, right? So mid key, if you just use this x1 plus x2 plus y1 plus y2, you're going to get 18. Same way if you see this point CD, so you are going to again get this, right? These two completely different segments accidentally got the same key, right? So in order to avoid this same key, actually what I'm planning to use, I'm going to use this thing in my code, right? So I'm going to calculate the mid key of A, B, and C, D. Here, if you see 18, 18, right, it is going to cause the collision. But their midpoints are, if you calculate the midpoints na, of these two. So 1 plus 5 divided by 2, 10 plus 2 divided by 2. That is nothing but 3 by 6, right? Right, AB. Same way here, if you calculate the midpoint, 3 plus 7 divided by 2 and 4 plus 4 divided by 2, that is nothing but 5 by 4, right? They are not the same midpoint, yet the VAD key merges them into one group, right? So program incorrectly subtracts trapezoids, right? So this I'm going to handle it. I'm taking x1 plus x2, just I'm multiplying it with 10,000 so that I will see some difference in the hash key that I'm going to generate, right? So this is never going to fail, right? So if you do this, this works because it separates the x sum and y sum by shifting the x sum into a higher range, right? So that's what. So here same example I'm taking, this I'm getting mid key here, I'm getting mid key here, I'm getting different mid keys, right? So no collision now. So this is just a way to do this. Okay, right? And definitely while considering this value, I keep the the constraints of this problem in mind, right? So based on that, I will just give some random value, right? Bigger value. Okay, that's the reason, right? Okay, these are a few things that I will keep in my mind, right? Okay, we discuss intercept, we discuss slope, we discuss midpoint. Okay, now here what I'm doing here, actually I'm showing you the dry run. Okay, so before dry run, right here I'm just giving the debug statements. I'm going to use these two words actually in my code, right? Slope to intercept and midpoint to slope. So what is it, this slope to intercept? So imagine you draw all the segments connecting pair of points, right? You create all the segments, right? Every segment has a slope, how steep it is, and an intercept, right, where it crosses the y-axis. These two things we are finding, right? These two things only we are finding, slope, intercept. There is one more thing actually after this. Okay, this map, I'm going to create a map. Okay, this map is going to group the segments that are parallel, same slope together. This map groups segments that are parallel, same slope together. For each slope, we are going to store the intercepts on and segments with that slope. Okay, let me just, oh, for each slope we store the intercepts of all the segments. For each slope we are going to store the all segments with that slope, right? Okay, why we need this? So trapezoids need at least one pair of parallel sides, right? They need at least one pair of parallel side, right? Only then they can form a trapezoid, right? Two segments are parallel if their slopes are equal, but intercepts should be different, right? If intercepts like A, B, and C, if this C value is also same, then that means they are existing on the same line, right? So if we know all the slopes and intercepts, we can count all pair of parallel segments, right? We can count all the pair of parallel segments, right? Okay, this is done, right? Now here, suppose we have four segments. Segment 1, segment is nothing but line, right? This one is having slope 1, this one is having slope 1, this one is having slope 0, this one is having slope 1. Intercept of this 0, intercept of this 2, intercept of this 1, intercept of this 0, right? So we are only seeing two slopes, 1 and 0, right? And my slope to intercept, it is going to look like this, right? So here if you see, 0 is occurring two times and 2 is occurring one time, 1 is occurring just one time. I am also going to do this in code. That's why I'm writing it in key value pair, right? 0's frequency is 2, 2 frequency, this side frequency, 2 frequency is 1, 1 frequency is 1. Okay, now we can see how many segments are parallel for each slope, right? How many segments are parallel for each slope? This is what we can see. Okay, we'll discuss that. Okay, now here I'm going to use this map as well, midpoint to slope. So each segment has a midpoint, the middle of the segment, right? The middle of the line. Sometimes two segments may be on the same line and share the same midpoint. These are not valid trapezoid sides, right? I proved it above. This map groups all slopes for each midpoint, right? For each midpoint, I am going to calculate the slopes, right? This map. If two segments share a midpoint and have the same slope, they cannot form a trapezoid because they are just part of the same line. Later we subtract these invalid pairs from our count. So let's say segment 1, 2, 3, slope 1, 1, 1, and midpoint of this is this 2, 2, 2, 2, 1, 1, right? So actually in my code, I am going to store this like this, not 2 into 10,000 plus 2, something like this I will use, right? I'm generating one key, right, for the midpoint. Okay, here I'm just giving the example as point as x1 and y1, something like this, but actually I'm storing it like this. Okay, so for this key, actually this is another key, right? So I'm going to store, so your midpoint to slope is going to look like this. Okay, so slope 1, 1, right? Here this, so for this midpoint, right, we have seen 2, 1 is occurring 2 times, 0 is occurring 1 time. Okay, this is what I'm going to see, right? Now here we see that at 2, 2, there are two segments with the same slope, so we subtract them from the trapezoid count, right? And layman's analogy, you can say slope to intercept, first one. I want to know all the sticks that are parallel. Midpoint to slope means, wait, some sticks are really just parts of the same stick. Don't count this, right? So this is what these two refers. Okay, now let's do the dry run of the code. Okay, we have already spent so much time. Okay, right. So these are the points, different points you have. So we will compute all segments, and for each segment we compute midpoint, key, slope, intercept for line equation, right? Then we see how slope to intercept and midpoint to slope get filled, the two things that I will discuss just now, right? So step one. So first I told you, for total 5 points, right? So different combinations we can form, right? P1, P2, then P1, P3, then P1, P4, then P1, P5, P2, P3. Okay, all these different, right? So for each pair we are going to compute the slope like this. We are going to calculate the intercept using the formula, right? This formula actually I have derived it further, right? I have derived it further, right? If you see this, somewhere here I explained, right? There's so much things. Okay, so I have actually derived this somewhere. This we do here like this here. Okay, or we'll do the check segments, right? And then we move to this point, then we calculate all this stuff, then later on for the line actually here, right? So this thing actually, this thing I have reduced it further, so I'm going to use this in my code, right? So in the dry run I'm just writing this, but we have to use this. Okay, so just keep this in mind, right? Let's come back. Okay, right, and midpoint key I'm going to use this formula, right? So for all these segments now I will use this formula. I will calculate the slope, I will calculate the intercept, I will calculate the mid key for all these points, right, one by one. So just go over this example: p1, p3, p1, p4, p1, p5. You can also check all this, right? There may be something, some mistake in this, right? But I don't think there will be any mistake, but just check whether you are going to get same vertical intercept and mid key, right? Whether you get the same values. I am expecting this to be correct only, right? Here you can just compare with this. Actually this is nothing but dry run. This is nothing but dry run using debug statements in the code, right? Same thing that I'm showing you up, same thing I'm writing it here in some other way, right? So this is what you need to do. Now after that, slope to intercept. So for this slope, how many intercepts are there? For this slope there are two intercepts frequency, right? -1 is occurring one time, 5 is occurring one time, right? Okay, and one here, only one. For this also there are two, right? 3 is occurring one time, 2 is occurring one time, right? So this is what I'm going to calculate, right? This map I'm going to fill with this. Now here, midpoint to slope I will also calculate group by midpoint key. So each mid key will have only one slope in above example, so no midpoint appears twice. So no midpoint conflicts means no invalid pairs, right? So here if you see, count parallel pairs, right? I'm counting like this. So frequency map I'm operating like this. Okay, the first map, right? And here midpoint conflict. So in all these midpoint conflicts, if you see now, I'm just getting one slope every time, right? I'm every time skipping actually, right? Same example like above, right? But here I'm calculating this. So here if you see, for this slope, which is, this is nothing but infinity actually, right? This is infinity. And for this one, right, -1. So we have 2 points, right? Calculate the frequency of this one, right? And then we are calculating this. So I am actually getting one here, I am actually getting one here. So overall the result I'm going to get is 2 because of these two, okay, in the debug statements. So here I'm creating one answer value now, so I'm going to keep updated that one. Okay, here 1, and here previous answer of 1 is 1, and here I'm getting one more 1, so I will get 2. Okay, something like this. All right, so this is what I'm doing here, right? So many segments have unique slopes, so they are rarely parallel. Many segments have unique midpoints, no kite conflicts, right? So like no kite conflicts, right? Or here, same mid. right? Slope is equal to -1 appears twice. These two segments are parallel in verb example, and slope is equal to infinity appears twice, vertical parallels, right? So these are the candidates for the trapezoid pairs, right? So this is actually what we need to do, right? There are a lot of mathematics actually, right? We see a lot of mathematics, so definitely you need a practice, right? You can make notes of it, maybe all these things, because these things are very important mathematical things, right? That is why this problem is hard, right? So now I'm going to write the code, and I'm also going to explain the code side by side, right? But I'm going to solve the code using the same story that I've explained here. That will be nothing will be different. Okay, so that's it. Let's move to the coding part. Okay, so let me just maximize the screen here, and now let's get started with the code, right? So first thing what you need to do here, just first calculate the number of points. Int n is equal to points dot length, right? And create one variable double infinity, right? Store the infinity value, so I can say 1 e9 plus 7, right? And first I'm going to create one map. Okay, slope is going to contain the list of intercepts, right? So here I'm just going to write map, and here double list of double, and here I'm going to write slope to intercepts, right, is equal to new hash map, and that's it, right? Now after that I'm going to create one more map, midpoint. I've explained this, right? Midpoint, it is going to consist of list of slopes, right? So many things will get cleared when I'm going to write the code, right? Code simple only, nothing complex, right? So here same thing I'm doing, but here let's name it as midpoint to slope. Let's name it like this, midpoint to slope. Okay, done. Now here create one variable int answer and set it to 0. Then my first step is going to be step 1. It is going to be build all line segments, and compute slope plus intercept, right? So in one go I will do this. Very easy loop. Int I is equal to 0, I is less than n, I plus plus, and here for let's first do one thing here. Let's create x1. Okay, I have to select the points, right? So x1 is nothing but points at I comma 0, right? So same way, copy this, and here this is nothing but your y1, you can say, and here points of I and 1, right? This is done. Now here you have to run one more loop, right? So let's say int j is equal to I plus 1, j is less than n, and here j plus plus, right? Clear? And now again you have to select points, right? So here I'm picking few points, right? And here after this I'm going to pick few points, right? So let's do it like this here. Now it looks good. Okay, so here let's say this is nothing but x2, right? And this is nothing but, let's say, y2, and here let's say it is j and it is j, right? So this is done, right? Now after that what we need to do, here we need to calculate the dx is what change, right? So here I can simply, let's say, x1 minus x2 or x2 minus x1, my choice, right? You can write anything, your choice also, right? Int dy is equal to, and here you can write y1 minus y2. Okay, and just make sure here if you are writing x1, then here also start with 1 only, right? Okay, so yeah, that's it. So now we have to calculate the slope. So I'm creating double slope, that is why I'm using its double here. Okay, because I'm dividing now. Double intercept, right? So here vertical line, right? Vertical line. So in vertical line, actually what will happen? In vertical line, what will happen? So in vertical line simply means that my x1 value is equal to x2, right? For one segment, for one line, if both the x values are same. So if the x value is same, that simply means I will see one vertical line, right? So if this is the case, then in that case I already told you that in that case our slope is going to be infinity, right? We will see infinity slope, right? So here I can simply write slope is equal to infinity, right? And intercept is nothing but common point, right? X1 intercept, I can say simply say x1, right? So x is constant, right? Here x is equal to constant. You can apply the formula of intercept, you will get x1 only, right? Okay, else if this is not the case, right? In that case, how you are going to calculate the slope? You are going to calculate the slope like this. So slope I'm taking double, right? So here I'm just going to do 1.0 into, and here y2 minus y1, okay, and here divide it with, here I'm going to write x2 minus x1, that's it, right? This is how you're going to write slope. So here we are going to write the formula, right? So the formula that I have shown you, right, for intercept. So same formula that I'm going to write here, 1.0 double, right? So I will get some double value only. And here actually there may be case when I will get some simple int value, right, with this complete visual, right? So in that case I'm not storing int in the slope, I'm storing double, right? So I'm just making sure multiplying it with 1.0, right? That's the meaning. Okay, so here the formula that I have derived, y1 into dx minus x1 into dy and divided with dx, right? Clear? Which formula? This one. This one, right? So y1 into dx minus x1 into dy divided by dx, this formula. Okay, so I'm writing this intercept. Now I have to told you, right, in the code I was saying many times that just normalize it, right? If you get a b c value as negative, just normalize it. Normalize means that if I get minus 0.0, so I can just simply write it as 0.0, right? This thing also we can normalize, right? Just simple normalize, right? So here I'm writing if slope is equal to minus 0.0, right? In that case you have to write slope is equal to 0.0, right? Same way, if intercept is equal to minus 0.0, then in that case you can simply write intercept as 0.0. Done, right? Now also we have to do one more thing, we have to find out a unique midpoint key, and for this also I told you one formula, right, to generate the hash key. So mid key, you can simply write it as like this, x1 plus x2, right, and just multiply it with 10,000, right, and plus here you can write y1 plus y2. Okay, done. And now we have to store the values, right? Store slope and intercept in the map, right? So here slope to, I can do one thing now, why we need to waste time. So here slope to intercepts, I'm writing y. I can make it slope to intercept only, na, intercept, right? Why I need to write intercepts? So just copy this slope to intercept, and here slope to intercept dot compute if absent, right? So just check if this particular key is there or not. Which key? Slope, right? It is a slope to intercept. In this slope I have to add the intercepts. So if this key is absent, right, so for this particular key, do one thing, create one array list, right? New array list, right? You have created one array list. Now in this array list, just add the value of the intercept that you are finding, right? So this is what you have to do, right? Clear? Now same way, same thing you have to write for what? For this midpoint to slope, right? So here you can just do one thing now. Midpoint to slope dot compute, right? Just copy this, paste it here, dot compute if absent. Here what? Here we are finding a slope. Here we are dealing with mid key actually as a key, right? So mid key, and here if it is not there, add array list. Otherwise we have to add here not intercept but slope, right? So this is what we are doing here, right? That's it. So this is done, right? This is done here, right? Okay, this is done here, right? Now our next step, what is going to be my next step? My next step is going to be count all pair of parallel segments, right? So let's do that, right? Count all pairs of parallel segments, right? So for all the slopes I have added the intercepts, right? What are the different intercepts? And for all the mid keys I have added the slope, right? Now here we have to count the all pair of parallel segments. So this is my step 1. So let's say this is my step 2. Step 2. Okay, so now here what I need to do? Okay, so here just iterate, right? We have to iterate over all these values that we are storing here for all the intercepts, right? We have to iterate over all the intercepts that we have in this slope to intercept, right? So I can do one thing here. I can say for a list of double of, let's say, intercepts in this slope to intercept, right? I'm iterating over all, right? So here in this I'm not iterating over the keys, I am just iterating over the values that I have. So here I'm iterating over all the values, right? Now if this size itself, right, if the number of intercepts, if intercepts dot size itself is equal to 1, right, then in that case we have to simply continue, right? Then in that case just continue, right? So here so many segments have unique slopes really parallel, and many segments have unique midpoints, so no guide conflicts, right? So here if you see when we are finding this, so we are skipping all this, we are only taking all this, right? So that simply means for this slope we have two intercepts, means we have two different lines, right? We have two different lines, right? That's the meaning of this intercept. Intercept is that intercept is nothing but this ABC value, right? We are calculating ABC, so two lines are same, right? Their slope will be same, right? uh, but this C value is different, means different lines, right? If the slope is same, right? If slope is same, right? So that is why if only one if we have only one intercept, right? If we have only one intercept, right, then in that case it's not valid, right? Then it's not valid. Okay, so that's what. Okay, so this is done, right? Here if size is not equal to 1, right, so here I'm going to create one map, double integer, okay, and let's say is frequency is equal to new tree map. All right, so here just what I'm doing, I'm iterating, right? So here 1 5 now, so 1 is occurring how many times, 5 is occurring how many times. So there may be case when we are getting -1 here 2 times as the intercepts, right? We can get this value as well, right? So what I'm going to do here, double D, I'm iterating over all the intercepts, right? Intercepts, and here frequency, okay, dot put, so check, put the value in this particular key, right? So double D, or you can say B, right? Double B, let's say, right? So here in this key, just check if this key is already there in your map or not. So frequency map name dot get or default. So if this key is already there, then take that value, otherwise take 0 in the starting and add the value. So I'm just counting the frequencies of all this, right? All this, right? So once I calculate the frequency of all this, right, then what I'm doing here, I'm creating int prefix value as 0, right? And then I'm going to write int count, and I'm just going to iterate over frequency dot values, frequency dot values, right? What are different frequency dot values that we have? Okay, so in my answer, I'm here taking the prefix value, right? I'm taking the prefix value, right? Here if you see, I'm taking this answer as 0 here, and now here answer is nothing but the current prefix, which is 0, and in this I'm just going to add the current count, and all these values are there in tree map, right? Higher value I will see above, right? Above, higher value I will see above, right? Okay, uh, here double in integer, right? So double is nothing but the intercept I'm iterating, right? So I will see higher value, right? Here I will see 5 first, right? Tree map, right? Okay, so this is how I'm going to do this, right? You can use a hash map also. I don't think it will create any impact. Just use hash map, right? Even if you do this, I don't think there will be anything bad, right? If you do this, okay. So in this way you can update your answer, and you can update your prefix as equal to count. What is this? What is this I'm doing? What is this? Okay, what is this? What is this stuff? Let's see. Okay, so here -1, -1 we have, and we have 5, right? So we have 2, right? So one line we have -1, right, which is occurring one time, and we have 5, which is also occurring one time, right? So this is one time, this is one time, only one trapezoid is possible, right? Clear? Let's say -1, and there is one more line whose this is -1, right? And here this one is having -5. Okay, so here -1 is appearing 2 times, and 5 is appearing 1 time. So 2 into 1, right? This can be 1, or this can be 1, right? So 2 into 1, right, in this case. Okay, so that is why I'm taking this, right? So here if you see, let's take the same example, prefix 0. So first time, let's say I see this, I see 2, right? I'm iterating over the values only, right? So 2 into 0, so I will get 0, and prefix as 2, prefix as 2, right? In current count is 2 now, so 2. Next time I see 1, so if I see 1, so count is 1, and prefix is 2, 2 into 1, answer is, my answer is, new answer is 2, and here this will become 3, right? So my answer is correct, right? 2 I'm getting, and total number of parallel lines I have seen until now is 3, right? So in prefix I am seeing I'm writing the number of parallel lines that I have seen until now. So that's why initially is 0. For very first time it becomes 2, next time it becomes 3, right? And here answer I'm updating side by side. This is what I'm doing here, right? Okay, this is done, this is done. Now step 3, just copy this. Step 3, here what we need to do, we have to subtract the invalid pairs, right? We have to subtract the invalid pairs, right? I can say segments sharing midpoint, right? So we have to now ignore this, right? Okay, so again do the same thing here. You have to just write slopes, and here midpoint to slope we have to iterate, right? And dot values here, if this slopes dot size is equal to 1, continue. And here we have to create one map. Okay, you can use hash map also. And here let's say k, and this is nothing but you can say slopes. So for this key, frequency dot get or default k value and 0 plus 1 and prefix 0 and count. You have to iterate and answer. Here you have to subtract it, right? And prefix you have to update, right? And in the end, once this is done, you have to return answer. This is your code. Okay, this is your code, right? Let's run it and let's see. There is some issue. Let's see what is saying. Int cannot be converted to double. Okay, line number 36, right? Let's see line number 36. All right, so here what we are doing, midpoint to slope dot compute if absent mid key and key new array list, and here I'm adding slope. Okay, so here slope value I'm adding, right? Slope I'm taking double. What I'm doing here in the map, and the map also I'm doing like this, right? So what it is saying, right? Here is mid key and key is equal to new array list dot add, and here I am adding slope. Okay. Okay, all right, all right. So what it's saying, incompatible types. Int cannot be converted to double. Mid key. Oh, I'm calculating the mid key. Oh, okay. Int mid key is nothing but this. Okay, so I think in top I'm taking here a double, right? So I have to change it to integer, right? So that is why I'm seeing this issue. Let's run it. So see, all the test cases has been extracted, right? Now let's submit it. So see, our solution is extracted, right? So that's a lot, right? Lot of mathematics. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.